Hi guys, today I'm going to be doing a video on SUVAT, and I know a lot of you might initially think, well, this is a science topic. It is, because it's covered in Physics 5, but the basis of it is mathematical, and someone asked me to do a video on it, so I thought I'd comply by doing it. So the first thing that we need to know is, what do these different bits stand for? So S stands for displacement, which is kind of the same as distance. The only difference is displacement is the distance travelled over a specific amount of time, like how far have you moved from where you started. But we'll keep it, the two can be used interchangeably most of the time. And U and V are quite similar, but also quite different. They are initial velocity and final velocity. And what that means is, say during something you accelerate, what the speed you started out at is your initial velocity, and the speed you end up with at the end is your final velocity, and you'll understand that a bit more later. A stands for your acceleration, which is how quickly your speed changes, and T stands for time. Now, you won't actually be given what these are in an exam book, but what you will be given in the front of the exam book are these equations. Now, you don't have to memorize these. What you do have to know is how to use them, because these are all given at the front of your Physics 5 at the front of your physics paper, but you won't be shown how to use them. Now, what these are is these are the various letters in here, and given a question, if you work out what numbers the letters represent, you can use them in these equations. But what you're also not given during the exam is you're not given what units to use, and most typically you use meters for displacement or distance, meters per second for both the velocities, meters per second squared for acceleration, and seconds for time. So they're the units. If you remember this, it allows you to use this. You're given this in the exam. So what I'm going to do now is I'm going to work through 3 examples of things you might find in exams or kind of similar situations surrounding P5, or you might just find them in your lessons. 3 examples for how to use these equations. So first one I've got here is a car is moving at 10 meters per second and then accelerates to 30 meters per second in 5 seconds. Calculate its acceleration. Well, the first step, what you always need to do is write out SUVAT and see what you know of these. So S, distance or displacement, you don't know this. There's no mention of how many meters were travelled at all. However, you do know the initial velocity, and that is 10, because in this case it's the velocity before acceleration. And then V is the velocity after acceleration, hence 10 and 30. Acceleration, we don't know, but we want to find out because we have to calculate its acceleration, and we know how long it took. It took 5 seconds. Now, in this question, we don't need to bother about displacement. So all we need to concentrate on are U, V, A, and T. And we need to find one of these equations that uses all 3 of these, because we want to find out what acceleration is. So there are many ones, there are at least 2 that we can use, but I'm going to pick A equals V minus U over T. So if we put in the numbers that we have, A equals 30 minus 10 over 5, which means A equals 20 over 5. Is A equals 4, and if we remember what units to use, meters per second squared. So in this example, the acceleration of the car is 4 meters per second squared. Now our second example is kind of similar but slightly different. A runner is going at 2 meters per second and then accelerates to 6 meters per second in 4 seconds. Calculate the distance they travel during acceleration. So again, first step, write out SUVAT and try and work out what we know. Now this time, the distance travelled during acceleration, that's what we want to find out. So we don't know that. Their initial speed before acceleration was 2. Their final velocity, after acceleration was 6. We don't know their acceleration, but we know the time it took was 4 seconds. Now for this example, we don't need to bother about their acceleration. Even though it says they accelerated, we don't need to know their acceleration for this question. So we need to find something that links S, U, V and T together. And I'm going to pick S equals U plus V over 2 times T. So again, put in the numbers that we know. We know 2 plus 6 divided by 2 times by 4, which makes 8 over 2 times 4, which makes 4 times 4, which makes S equal 16 meters. Because if we look over here, we know that for displacement or distance, for S, the unit is meters. And so they travel 16 meters during the time of acceleration. And the final example that I'm going to do is this one. A lorry begins stationary and then accelerates at 0.5 meters per second for 12 seconds. How far did it travel during acceleration? Well, as you know by now, first step, write out SUVAT. And we don't know distance, but how far did it travel? Well, that's a distance, so that's the bit we need to work out. We don't know, we do actually know its initial velocity because it doesn't appear like it at first, but it said the lorry begins stationary, and stationary means it's not moving at the start, so its initial velocity is 0. However, we don't know its final velocity, but we do know its acceleration is 0.5, and the time it took was 12, so we don't need to bother with final velocity this time. We need to find something that links S, U, A, and T. So I'm going to use S equals UT plus half AT squared. Again, put in the numbers that we know, 0 times 12 plus 1/2 times 0.5 times 12 squared. This bit is 0, so we can kind of get rid of that. And 1/2 times 1/2 is 1/4. 12 squared is 144. And 1/4 of 144 is 36. And because it's a distance or a displacement, we use meters. So they travel 36 meters during its acceleration. So what I've done there is I've just shown you 3 examples for how to use the SUVAT equations. What you need to remember is you are given these during the exam, but you just need to remember what all the different symbols stand for and the units that they need. And then when you're given a question, write out SUVAT, write in the numbers that you know, work out which one you're trying to work out, find an equation that uses those ones that you either have or need, and then solve it through to get your answer. And that is the basics of SUVAT. I hope you learned how to do this, and I hope this helps both in physics 5, and if anyone does or goes on to do A-level maths, you also do SUVAT then as well. So hope this was helpful. Thank you for listening. Goodbye.